Hi and welcome everyone to our video for panels. So in this lesson we are going to discuss the construction of panels or electrical panels and the SLD or the single line diagram for the panels. So if you are new to our channel, don't forget to subscribe to our channel and hit the like button, and don't forget to hit the notification bell in order to get all of our last videos in electrical engineering. So let's start by understanding the construction of the panels or panel boards, or sometimes they are called as distribution boards, or sometimes called as electrical panels. So as you can see here, this is an electrical panel. Let's see what is the construction or what are the components of the panels. So we'll find inside this panel the circuit breaker or the main circuit breaker. You will also find the busbars, a group of busbars, which contains the RST or the three phases, plus N plus E. N is the neutral and E is the earthing. So we have 5 busbars, 3 phase, neutral and earthing. We will see each of these components in the next slides, but we are just giving an overview about panels. So there is also outgoing circuit breakers or fuses. We also have inside panels digital meters which have a voltage, which measures the voltage, the current, the active power, the apparent power, reactive power, power factor, and so on. And we also have indicator lamps inside the panels. You will find inside panels we have CT and VT or the current transformer and voltage transformer. We also have insulations. Now let's start by the main circuit breaker. The main circuit breaker, which is can be any of these types, an air circuit breaker, it can be molded case circuit breaker, or miniature circuit breaker, as you can see here. Each of these circuit breaker we can discuss in another video, but we are just giving an overview about circuit breakers. So this is the main circuit breaker, this one, which can be any of these types, as you can see here. So what is the function of the main circuit breaker? It's used for protection of the panel against short circuit or overloading. So it has a different types, as we have seen: MCCP or the molded case circuit breaker, or MCP or the miniature circuit breaker, or ACB or air circuit breaker. So the circuit breaker or the main circuit breaker, it takes the incoming or the connection between incoming and the outgoing cables to busbars. So we'll see all of this stuff in the next video or in the next slide of the busbars. Now if we look carefully about the busbars here, you will find this is the busbars. As you can see here, red, yellow, blue, or RST or the 3 phases here. You can see this circuit breaker, which is the same one as here. This one is the main circuit breaker. Okay, this one is the main circuit breaker. So as you can see here, the incoming cables, the incoming 3 phase, yellow, red, yellow, blue, the 3 phases are going to the circuit breaker, and then there is outgoing bus bars, as you can see here. This 3 bus bars, they are a connection between the incoming power and the distribution of electrical power. So as you can see here, this main circuit breaker is used to protect the panel itself. So if there is an overloading condition or a short circuit, it will cut off the circuit in order to protect our panel. Now as you can see here, there is outgoing fuses or circuit breaker, here in this case circuit breakers. As you can see here, each of this circuit breaker going to a sub-circuit. So let's draw it to make it sure. This one, for example, this circuit breaker is connected to, it has a 3 black lines, as you can see here. One is connected to the red, another one to the yellow, another one to blue. Then it will have yellow. Here you can see the blue, the yellow, and the red. Okay, so this is called outgoing circuit breaker, which takes from the bus bars the electrical power from bus bars and go to a circuit such as lighting, sockets, and so on. So as you can see here, so if we get back here, you will see here this circuit breakers. Okay, these are circuit breakers. As you can see here, you can see red, yellow, blue. Okay, red, yellow, blue, which means this is this one is for the phase for the red, this one for the yellow, for this one for the blue. Okay, this is of course in case of a single phase circuits. Okay, if we have one only for the red, another one for yellow, another one for blue, then it means that each of these going to a single phase circuit such as lighting or normal sockets. Okay, so this is the main circuit breaker, this is the outgoing circuit breakers. Okay, each of them is connected to a phase, as you can see here. Now you can see here that the bus bar is the connection between the incoming cables which will provide electrical power to this bus bars, 3 phases connected to 3 bus bars, giving them electrical power. Then this bus bars, from it you will see connections here. You can see cables connected to each of this bus bar. Each circuit breaker, if it is a 3 phase for example, it will take from red, yellow, blue. This one for example, as you can see here, 3 cables, one from blue, one from yellow, one from red, and so on. Okay, so the bus bars, it is used for transferring electrical power from the incoming feeders to the outgoing circuits, as you can see here. They are made of copper and fitted on insulators, which depends on the value of the voltage, which of course the insulators are used to insulate this bus bars from the enclosure itself, okay, to prevent the connection of this bus bar with the ground. The bus bars are coated with insulating material such as PVC or polyvinyl chloride in order to protect them against moisture and harmful gases. The bus bar selection depends on the rated current, the short circuit level, and finally the size of the panel. As we discussed now, this outgoing breakers, or sometimes they can be fuses. They are used to protect the outgoing cable to the load. These cables, as you can see here, this outgoing cables, and at the same time, of course, the outgoing cable and the load itself. The load, which such as the lighting, the normal sockets, the power sockets, air conditioning, motor, and so on, against short circuit or overloading. They can be monopolar in installations and circuits that have only a single phase, such as lighting circuits and sockets. So what does a monopolar mean? It means that it is one phase, okay, such as this one. If we get back here to this one, you can see that this one is a monopolar. You can close one phase only. Okay, so this one, this circuit breaker is connected to the red phase, so it is a monopolar, connected to only one pole or one phase or whatever. So we can switch this phase on and off by controlling this switch. Okay, so this one is called a monopolar. It's connected to a single phase circuit, okay, such as lighting circuits and normal sockets. And also they can be bipolar, connected to 2 phases, or 3 pole, connected to 3 phases circuits. For example, the 3 pole can be in a 3-phase motor, okay, or a 3-phase induction motor. Also, we have the measurement devices and indicator lamps. Indicator, not indication, indicator lamps. So as you can see here, indicator lamps, as you can see here. Okay, and we have the measurement device, such as it can be digital meter like this one, or it can be analog meters like here. You can see the amperes, the voltage, the frequency. Okay, and this one is a miniature circuit breaker. Okay, and this is the main circuit breaker, which is a molded case circuit breaker. They are used to measure or provide voltage, current, power consumed, frequency, and more. They are used to provide the measurement or the measurement signal. Okay, so as you can see here, this one measures, for example, the voltages. This one measures the currents. This is an analog, for example. This one measures the voltage, analog. This one measures the frequency. It can be a digital or analog meter, such as this one, digital meters, or analog meters like here. The indicator lamps, these indicator lamps, what does they do? First, they are supplied directly from the incoming feeders. They are used to reflect the working state of the circuit, such as is the circuit in the operation state, working state, or it is shut down state, or it is in testing state, testing the panel. And also it provides the position state, such as it is a closed circuit or a disconnected circuit. Okay, so that is the benefit of the indicator lamps. Another thing inside our panels, we have the CT or current transformers. As you can see here, for example, this is a main circuit breaker. Okay, and it has the incoming 3-phase, for example, going to the circuit breaker, or a 3-pole circuit breaker. And then outgoing bus bars. Okay, you can see this bus bar, this bus bar, this bus bar, 3 outgoing bus bar. Around them, you can see this one, which I am pointing at, is called the CT. You can see here 3 CTs in order to measure the 3-phase current. Okay, so this one, or the current transformer is used for what? Is used for the measurement of current. So they are used to measure the value of the electrical current. It is made of one coil, which is considered as the primary coil of the transformer. Okay, as you can see here, one coil, which is inside this box. This current transformer has one coil surrounding the bus bar, or surrounding a cable. Okay, so this one is surrounding the bus bar. As you can see here, this CT or this coil is surrounding the phase, okay, or the bus bar. So it has one coil, this coil, which is considered as the primary coil of the transformer. This primary is connected to the ammeter, okay, which gives us the value of the current. Now the conductor, which is such as a bus bar or a cable, okay, this one, which is carrying the current, is considered as a secondary coil of the transformer. Since we are talking about CT or a current transformer, we have a transformer, which means we have a primary coil and secondary coil. So the primary is the current which is flowing inside bus bar or the conductor. And the secondary coil is the coil here. This coil, which is inside this box, is the one which has a current, another current, which is a secondary current. Okay, so as an example, we will have 100 ampere, just for assumption, 100 ampere inside this bus bar. Then by using a transformer ratio between the primary and the secondary coil, we will have, for example, a 5 ampere here. Okay, so this current transformer is used to step down the current, reduce the current in order to measure it. Some important notes about panels. Number 1, the outdoor panel has an IB, or ingress protection, or sometimes called the protection index, of 65, IB 65. So what does an IB 65 mean? It means the first number representing the protection against solid particles, okay, such as dust. The second number representing the level of protection against liquid or water. Okay, so we have here a 65 compared to the main distribution board, or MDB, main distribution board, which has an IB of 54. You can see that it is lower than the outdoor, because the outdoor is more exposed to atmospheric conditions or outside conditions. Okay, so you will see the IB is lower. Now if we go deeper inside the distribution system, we will have sub-distribution board, so which has an IB of 44, which is less than this one. So what is the difference? The difference is that the outdoor is the biggest panel, which is the outside, which provide to main distribution board or a group of main distribution board. Then the distribution boards or the main distribution board provides electrical to different or many sub-distribution boards. Okay, so this is the one provides to this one, and this one provides to this one. Okay, the thickness of the panel itself should not be less than 2 millimeters. And of course, we have to earth our panel or the enclosure of the panel. It is, of course, important. Now, let's see an example of the panel drawing or the single line diagram for the panel. So we have this system. We have a panel supplying electrical power to 3 of 30 horsepower motors and 2 of a 20 horsepower motors. So as you can see here, this one is a 30 horsepower, this one is a 30 horsepower, this one is a 30 horsepower, and 20 horsepower, 20 horsepower. All of these are 3-phase induction motors. Okay, so let's see what exactly happened here. So as you can see here, this is the incoming cables. Okay, RST, which are the 3-phase, neutral, and finally the earthing. Okay, so we have 5 cables. The 3 phases are ST, neutral, and earthing. You will find that usually that due to the different in case of the unbalance, you can see that here are ST or the 3 phases 150, 150, 150. This values depends on the value of the current. Okay, the cross-sectional area itself depends on the value of the current. So we have here the neutral is usually half of the phase cross-sectional area. So you can see that the half of the 150 is nearly 70 millimeter square because it is the neutral. Neutral usually half of this phase values. So this goes to the circuit breaker here, molded case circuit breaker, to rated current of a 250 ampere, short circuit current of a 25 kilo ampere. So we have R, then S, then T going to this circuit breaker. Okay, and this is the bus bars here, as you can see here, R, S, T, and neutral. Okay, for the bus bar, 4 bus bars here are ST and neutral. So you can see that the 3 phases RST is connected to the first one R is connected to R, second one S connected to S, T connected to T, neutral is connected to the neutral. Okay, without of course the circuit breaker. You can see that this is a 3-pole circuit breaker, takes the 3 phase only, it doesn't take the neutral. Okay, so the bus bar here is considered as the connection between the incoming feeders and the outgoing power. So as you can see here, this as an example, this motor, 3-phase motor, takes the 3-phase and the neutral. So you will see that this is a circuit breaker which protects the motor of 63 ampere as a rated current and 25 kilo ampere as a short circuit current. This is a molded case circuit breaker. You can see that it takes the R, S, and T going to the circuit breaker, and we have here R, S, T going to the motor, and finally the neutral. Okay, similar to this, the other motors, you will find here 3 phases RST and the neutral. Okay, so we have the bus bar connecting between the incoming and outgoing. Now the most important thing is the earthing here. Earthing, you will find that the earthing here is a similar cross-sectional area of this incoming neutral, 70 millimeter square, 70 millimeter square. Now this is the earthing bus bar. Okay, which takes all of the earthing at one point. So you can see here, what does this, the function of this one is that we earth the enclosure of the motor. Okay, so this one is the earthing for the panel. This one is the earthing for the enclosure, going here like this to the earthing bus bar. We take this point, which is the earthing or the earthing of the enclosure itself, earthing of the enclosure, earthing of the enclosure, and so on. Take all of this as a cable going to one single point for the earthing system. Okay, so now this drawing, we would like to convert it into a single line diagram. So we have a 3 incoming, 150. Okay, so 3 multiplied 150 plus 70 plus 70. So as you can see here, distribution board, you can see 3 multiplied by 150, which means 3 phase, multiplied by 150 millimeter square, plus 70 plus 70, which means we have a 70 for the neutral, 70 for the earthing cable. You can see here copper, PVC, PVC. What does this mean? It means that the copper, which is the material of the conductor, PVC is the material of the insulation of the cable. PVC here, the second PVC, it is the outer sheath for the cable. So we have conductor, insulation, outer sheath, which is made of PVC. This one can be PVC or XLPE or cross-linked polyethylene. Okay, so this one, 3 cables plus 70 plus 70, which is the same representation of this one, 3 150 plus 70 plus 70. Okay, going to a circuit breaker, 250 25 kilo ampere, 250 ampere molded case circuit breaker, which is, this is the symbol of the circuit breaker. Going to a bus bar. Okay, 25 kilo ampere here representing the short circuit of the bus bar. 50 hertz is the frequency. 380 volt is the line to line RMS value of the voltage. Okay, then we have some digital meters, and you can find here earthing bus bar. Okay, now outgoing to it, we have this one similar to this one, similar to this one, 30 horsepower, 30 horsepower, 30 horsepower, 20 horsepower, 20 horsepower. So we have here X2 and X3. X3 for a 3-phase induction motor, 30 horsepower. X2 to a 3-phase induction motor, 20 horsepower. You can see here the circuit breaker itself, molded case circuit breaker, 40 ampere, 63 ampere molded case circuit breaker, which is the same breaker used here, 63, 40 ampere, 40 ampere and 63. You will find here the outgoing cables. Okay, as you can see here, we have 1, 2, 3, and 4 cables, 25 millimeter square. Okay, why? Because they are a multi-core. One cable which has the 3-phase and the neutral in one cable, so they have the same value. And finally, the earthing of 16 millimeter square. So you can see here, this one, 4 multiplied by 25 plus 16 millimeter. 4 multiplied by 25 is the 3-phase plus neutral. 16 here is the earthing. Similar to this one, 4 multiplied by 16, 4 cables multiplied by 16 millimeter. So 4, which means a 3-phase, neutral, 16 millimeter, plus 16 or plus the earthing of 16 millimeter square. You can see here copper, PVC, PVC, okay, which is the conductor, insulation, and outer sheath. Okay, so we represented here the single line diagram for this large system in just an easy method like this. Let's see another example. This is the second example. We have 10 millimeter square, 10 millimeter RST and neutral and earthing. Okay, so this is going the 3 phases, going to a 3 pole circuit breaker, molded case circuit breaker. Okay, Then the outgoing, similar to as before, going to a bus bar or SCT and neutral bus bar, and we have an earthing bus bar here. Okay, so the earthing of the panel goes to here, and earthing of each of this circuit goes to this the same one, similar as the motors here. Okay, so this one is the earthing for the lighting circuit. So in this example we have a panel, okay, a panel supplying electrical power to two lighting circuits. Okay, so they supply electrical power to two lighting circuits, two normal socket circuits, and two power socket circuits. So as you can see here, we have two lighting circuits, lighting, normal socket, power socket. Okay, so you can find each of these circuits is a single phase circuit, which is different from this one. This one was a three-phase motors. This one is a single phase. So as you can see here, you can see, let's start from here, takes one from the R, one from the neutral, R and the neutral. Second one, S and the neutral. Third one, T and the neutral. Then the fourth one, R and the neutral. Lighting, S and the neutral. Lighting, T and the neutral. So as you can see here, one phase, which is can be T or S or R, and the neutral, since it is a single phase circuit. And you can see here the breaker, miniature circuit breaker, which is used to protect each of these circuits. Okay, and you can see here one for the phase itself and the other one for the neutral. Phase, neutral, and so on. Okay, so why do we do this? Why R, then S, then T, then R, S, then T? Because we are trying to reduce the unbalance between circuits. Okay, we have to reduce the unbalance as possible. Now, if we would like to represent this one like this, we will start by DB, or the distribution board. We have how many incoming? We have 1, 2, 3, 4, and 5. So we have 4 multiplied by 10 plus 10. Okay, 4 multiplied by 10 plus 10 millimeter square, which is 3 phase neutral multiplied by 10 millimeter square, the cross-sectional area of the cable, plus 10. The plus 10 here means the earthing system. So we have copper, PVC, which is the conductor, insulation, and finally the outer sheath. Okay, this cable is going to a molded case circuit breaker of a 25 ampere. This one. Then this one connected to a bus bar, 25 kilo ampere short circuit, 50 hertz, 380 volt, which is line to line RMS. Then we have outgoing circuits. We have a 2x2, two lighting circuits, two normal socket circuits, two power socket circuits. Okay, we have outgoing breakers, which protect the cable here and the circuit. So we'll find that we have how many lines? We have 1, 2, and 3. Okay, 1, 2, and 3. So you can see here 3 multiplied by 3 millimeter square. What does this mean? It means that we have the 3 here multiplied by 3 means that we have a phase of a 3 millimeter square, we have a neutral of a 3 millimeter square, and we have earthing of a 3 millimeter square. Similar to here, 3 multiplied by 3, 1 phase, 1 neutral, 1 earthing. As you can see here, 1 phase, 1 neutral, and finally the earthing. Okay, similar to here, this one, 3 multiplied by 4, 4 here is the millimeter square. The first one is the number of conductors. So we have a 3 conductors, or the 3 different phases, such as neutral phase earthing multiplied by 4 millimeter square, or the 4 millimeter cross-sectional area. Now, final thing is that the types of the panel, we have 3 main types of panels. We have a UPS panel, then we have a normal distribution board or panel, and we have the emergency panel. Okay, so remember that we have three main types: UPS, normal panel, emergency panel. Okay, so as an example, this electrical drawing, you will find here the symbols. This one representing a single socket, this one is a power socket, this one is a luminaire. Okay, if you don't know a luminaire, just for simplification, it can be a lamp, for example, or a lighting circuit. This one is a UPS socket. So let's understand what does this single line diagram represents. So as you can see here at the beginning here, we have a transformer. Okay, so this part, this one, representing the incoming electrical power from the power grid. So this one is the main supply from the power grid. This one is a standby generator or sometimes emergency generator. Okay, which is called an emergency power. So this is the main power from the grid. This one is the emergency generator. This one is the UPS or the uninterruptible power supply. We discussed it before in another video. Now you can see these are three sources of electrical power. Now let's understand each what happening here exactly. In the normal operation, you will find here we have 1 bus bar, 2 and 3. So we have 3 bus bars. So what exactly happens is that in normal operation, the circuit breaker number 1, this circuit breaker, and there is a circuit breaker here. Circuit breaker number 1 is on and circuit breaker number 2 is off. So this one is closed like this. This one is closed like this. And second circuit breaker is off, which means this one is opened. Okay, this one is not connected. So what happens is that the electrical power will supply electrical power to this bus bar. Okay, and the electrical power will go like this to this bus bar 2, supply electrical power to this bus bar and this bus bar. So these two bus bars have electrical power. Now what will happen is that the electrical energy will go, or electrical power will go through the normal distribution port. Then it will start supplying electrical power to this power socket, to this normal sockets, circuits. Then it will supply some lighting circuits, some of them. Okay, this lighting circuits. Okay, this one outside here. Okay, you can see 6 luminaires, which are the one which take power from the normal distribution board. Okay, now from the other side here, from this side, what will happen is that it will supply electrical power to the emergency board and to the UPS. Then the emergency board here, this one, will supply electrical power to the 3 remaining luminaires. This 3 luminaires, this one, and finally this one. Okay, then the UPS itself, it is charged and at the same time supplies power to the UPS distribution board. Then it will be connected to the most important or critical equipment, such as the computers. Okay, so because we would like it to keep running all the time. Okay, even if the electrical power failed, because they have important information. Okay, so we have, this is in the normal case, all of our system is now working. Okay, so let's delete all of this and see if we are in the cut-off state. Circuit breaker number 1 will be off, circuit breaker number 2 will be on. So this one will be off and this one will be on. It will be connected like this. So what will happen is that since there is a failure in the electrical power system, and the failure, so no electrical power will go to this bus bar, and this circuit breaker number 1 is opened, which means it will have no electrical power here. Okay, so the electrical power will come from the generator here, supplying electrical power to this bus bar. This bus bar will start supplying power to the emergency panel and at the same time to the UPS panel. Okay, So we will have electrical power to the 3 emergency luminaires, as you can see here. And at the same time we'll supply electrical power to the UPS to keep it charging. And the UPS will keep electrical power to this critical equipment. This is the emergency state. So as you can see, all of this are out. No electrical power. These luminaires are out. This one is out. This one is out. Except the 3 here. Except those three. Since they are connected to the emergency panel, so that people can see and walk in the corridor, for example, or in rooms. So they keep 3 panels connected to the emergency generator. Okay, now you will have to understand that this generator, for example, will take 30 seconds, for example, in order to operate. So during this time, this panels or this luminaires are shut down or off. But in this case, this equipment will still operating. Why? Because they are connected to the UPS. UPS starts providing electrical power to them to keep them running. Okay, so this is the most important component or equipment. So we connect it to the UPS, and this component will operate in normal operation and even in the emergency operation all the time. Okay, now you have to understand that we have here something which is called the ATS, or the automatic transfer switch, which is 1 out of 2. What does this mean? It means that it has 2 conditions or 2 switches, which is here, for example, 1 and 2, circuit breaker number 1 and 2, and one of them will be running. For example, if circuit breaker 1 is operating, then this one will be off. If, for example, this one is operating like this, then this one will be off. That's why it's called the 1 over 2. What does this mean? Means 1 out of 2. 1 circuit breaker operating out of 2. What does the ATS used for, or the automatic transfer switch? It is used to move from the main supply here from main supply here to the generator here, to the emergency generator, or from the emergency generator into the main electrical supply by switching between circuit breaker number 1 and circuit breaker number 2. So this video was about the panels. I hope this video was helpful for you, but before we end, we have something here, MLVDB, which means the main low voltage distribution board. Okay, and as you can see here, all of the elements which we discussed before, the same as the single line diagrams which we talked about in the previous slides. So I hope this video was helpful for you. Don't forget to subscribe and hit the like button, and tell me in the comments if this video was helpful or not. Thank you, and see you in another lesson.